Hello, everyone. Lesson 3, Unit 5, summation notation. I told you this one isn't too bad. Mostly calculator based. Usually you see it on like a part 1 of the Regents exam. So summation notation sounds like sum. So that is why you are adding the terms of a sequence. So your generic summation notation is right here. It's an interesting little writing specimen I have here. I don't know what I'm on, but anyways. Okay, so I equals A, F of I, N. This is the summation notation. So like, what the heck are all these letters? Okay, they don't always use I. They could use K. They could use N. They use K up at the top. They use all different letters for this. What you're essentially doing is whatever the A term is, that's where you start. So your F of A is your starting point. And then it goes up in order all the way to N. So A and then A plus 1 plus 2 plus 3 all the way to N. I know it's rather difficult to understand, comprehend when you're just talking about variables, but when you substitute in actual values, it makes sense. So with this one here, A, summation of I equals 3 to 5 of 2I. So if this is a part 1 question, then you can go right to your calculator, and it's the summation. So to the right of the 9, you press this button, to the right of the 9, and then there's your summation button right there. Then you hit enter, and use the letters they use. Make sure you choose from the bottom of your calculator. So it's I equals 3, and then wherever it takes you, put the next one in. So then it's 2I, and then up to the top would be 5. And then you hit enter, and that's your answer is 24. So this answer is 24. So like I said, on a part 1 question, that will suffice. Okay? Part 2, if you have to show all your terms. So I is 3, starts at 3, and goes to 5. So there's only 3 terms, so 3, 4, 5. So that means that you start substituting, so you have 2 times 3 plus. Okay? 2 times 4 plus 2 times 5. Okay? So then this gives me 10. This gives me 8. This gives me 6. I add these all together, and I get 24. So that's essentially what's going on. Okay, that's it. That's all you're doing. So when you get to the next one, it goes from -1, 0, 1, 2, 3. I don't want to go into this space here. And it's k squared. So squared, 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 squared. Okay? If you put in your calculator, of course. I'm not going to keep doing every one in the calculator. Put in your calculator. Unless it gets to a difficult one, then I'll show you. Oh, there's your K, which I said. It could be any value down there. So you have your K. Goes from -1 up. And it's K squared. So there's your K squared. Up, up, into 3. Enter, and you get 15. Okay? So that's the answer they're looking for. So this equals 15. Like I said, if it's a part 2 question, you have to show me all that. I don't know if it'll ever be a part 3. Okay? Letter C, you plug it in your calculator, you get 7.75. D, you plug it in your calculator, you get -1. E, you plug in the calculator, you get 9. And F, you plug in the calculator, and you get 20. I guess I'll show you E. So 0, 1, 2. So 2, 0, plus 1, plus 2, 1, plus 1, plus 2, 2, plus 1. Okay? So that's why I said, I told you in class it's not this difficult of a lesson. It's not that bad. It's a good way to start Monday. Okay, or start your weekend, whatever. Okay, so there's your 1 plus 3 plus 5. 5, 8, 9. There's your 9. Okay, so you just plug it right in, okay, for your variable. Now, there's your part 1 right there. So which of represents the value of? So which represents? I don't know why there's an of in there. Okay, so we'll get rid of that. Okay, so again, go right to your calculator, do your summation symbol, and this one is I equals 1. And it's okay if it's a fraction. Don't be scared. Control fraction 1 over I. And then back up top to 4. Enter. And it is 25 over 12. Okay. Choice 3. All right. 25 over 12. Choice 3. All right. So not too bad. Now, there are instances when you cannot use your calculator to do it. So when is that? That is right here when we have a sequence that is defined recursively. So we need to find 4, 5, 6, and 7. And we need to add those together. In order to do that, I already have A1 and A2. So that means I have to find A3. So A3, okay, what is that value? That is A2. Okay, so A2 plus 2, AN minus 2. 3 minus 2 is 1, 2A1. Okay, which equals 2 times 1 plus 2 times 0, which is 2. Okay? Oh my gosh, I don't know why you guys are going to be so mad at me. There's no 2 here. I don't know why I put a 2 there. Okay? That's just supposed to be a 1. See how it's AN minus 1? Alright, it's just supposed to be a 1. I don't know why I threw a 2 there. Sorry. Gosh, don't be so mad. Alright, so here we go. Find the fourth one. It's the previous term. And now I lost my good writing too. I don't know how. Okay? So it's 1 plus 2. There we go. It's back. 1. Okay? Which is 3. 5 is the previous term. So term 4, which is 3 plus 2 of term 3, which is 1, which gives me 5. 6 is term 5, which is 5, plus 2 term 4, which is 3, which gives me 11. A7 is term 6, plus 2 term 5, which gives me 21. Okay, so I only want from 4 to 7, 8, 9, 10, and then carry the 1, 2, 3, 40. Okay, so sometimes you have to find the recursive sequence, plug it all in like we did in the previous sections, okay, and then add them all together. Sometimes you have to express each sum using sigma notation. So they say use I as your index variable. Now the key thing with these index variables is they don't have to start like your arithmetic and geometric sequences. They don't have to start with 1. They can start at -1. They can start at 0. They can start at 3. They can start wherever they want. Okay, so depending on what notation you use and the little formula that you use or the expression will depend on your I. Okay, so we'll look at this and try to figure out what's going on. So I look at these numbers here, 9, 16, 25, 100. Okay, what are they? Those are perfect squares. Okay, so what's 9? 9 is 3 squared. 16, 4 squared. 25, 5 squared. 100, 10 squared. So, and there's a summation. So there's my summation. Now it says to use I. And I'm going to say I'm going to start at 3 and go to 10, and it's just I squared. Because that's all you're doing is squaring it. Okay? Now, this one here, what's happening here? Okay, -6, -3, 0, 3, blah, 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 up to 15. So what it looks like from here to here. To get from -6 to -3, I have to add 3. Okay, so I have my summation. Now, again, the summation will start, will end however you want it to. Okay, depending on what your expression is. So if I start at -6, and I'm going to add 3, okay, and I'm going to make that an I. My very first term has to be -6. So therefore, this is non-existent. So my I would equal 0. Okay, it has to start at 0. So that way when I put in 0 for the first term, gone, -6. Put in 1, it gives me 3. So how high do we need to go? So this is going up by 3, so we have 3, 6, 9, 12. So this is 0, 1, 2, 3, 4, 5, 6, 7. Okay, so it goes from 0 to 7. All right. Now the last one, what's going on here? How are we getting from 125 to 1/5 to 1 to 5? We're multiplying by 5, it looks like. Okay, a little more tricky. Okay, or I'm looking at this as 1 over 5 squared plus 1 over 5 to the first plus 5 to the 0 plus 5, 1. 5 to the 0 is 1. This 5 would become 1 over 5 squared is 5 to the -2 plus 5 to the -1. Okay, that's a 5 right there. Okay, so 5 to the -1. So my summation notation has I starting at -2. And what are we doing here? 5 to the I power. 625, how do I get 625? 5 times 5 is 25, times another 5 is 125, times another 5 is 625. So it's going from -2 to 4. Okay? Now when you get to this one here, exercise 5, you look at the starting point. Okay, where does it start? And the first term we need is a 3. So if I plug 1 in here, 3 to the first power, yup, is 3. That's good. 0, I plug 0 in there. 3 times 1, 3 works. Plug a 0 in here. 0 minus 1, -1. 6 to the -1 power is 1/6. See ya. Okay. Here, I plug a 3 in there. Okay. Yup, it works. Okay. So from there, you go to the second one. Now, this term, output, we need 6. We already did 1, so 2. 3 squared is 9. See ya. All right, the next one is 1. 2 to the first is 2. 2 times 3 is 6. That's still alive. Okay, then from 3 we go to 4, which becomes I, which is just 4. No good. Okay, so it's 2. Okay, so sometimes that's just a substituting in part 1 with the multiple choice and figure out which one works. I'm not really worried about exercise 6. If I have time in class on Monday, I'll show you that. Okay, it's just showing you like a telescoping series. It's something that we get into a little further in math. So that's it. We will see you in class.